So there we go. All right, we had started working with algebraic proofs, but we haven't yet gone over what to do whenever they give us two statements versus just one, how to combine them. We did on Monday practice using transitive and substitution a lot, so that should help us moving forward. Okay, so with your 2-column proofs, just remember the first line, line one is for your given statement. Now, if you're given two statements, you're going to take up 2 lines, et cetera, et cetera. X plus 3. Okay, now in one of my classes, I did have one student that decided to work out the problem and then just fill in the boxes, and I thought that was a very good strategy. That way you're able to, not everything is, that way it just keeps everything nice and clean. So to solve this equation, what do? We subtract 1 from both sides. And when we do that, we get 3 equals what? All right, then what's the next step from there? To get not 5, it gives us what? 11. And then we what? Divide by 4. Notice here, this is where a lot of students will go ahead and write x equals 11 over 4, but x has yet to move to the other side. So make sure you're bringing it straight down. So right now it's 11 fourths equals x. And remember, we have a special property that we use to flip them around. So just keep that in mind whenever you're filling in these boxes, okay? Now, the first thing that we did was subtract. So that would be your subtraction property. Okay. Now, because subtraction and substitution are so close, or the first 3 letters are the same, make sure you add 4 or 5 letters, okay? And whenever we subtracted, we ended up with this line. So we end up with 3 is equal to 4x minus 8. The next step was to add 8, meaning we used addition property. Okay. And when we added the 8, we end up with 11 is equal to 4x. Next step was to divide the 4 using division property. When we use the division property, it doesn't switch the x to the other side. We just bring it down and we have x equals 11 over 4. They want us to prove that x is equal to 11 over 4, not 11 over 4 equals x. So we do have to switch it around using what property? Symmetric property. Okay? Symmetric property of equality. So just remember, right now, we've only gone over properties of equality and properties of congruence, but we're going to end up using definitions, postulates, theorems. So it's just going to expand. Your little word bank here, your property bank is just going to expand. With congruence, this one we have 2 given statements. They're separated by the comma. So each one gets their own line. A, B, C, congruent, D, E, F. Angle D, E, F, congruent to J, K, L. Now, when you're combining 2 statements, remember you use either the transitive or substitution. But what is the biggest difference between substitution and transitive? only a part of the equation or congruent statement versus the whole side. So with 1 and 2, what do we have in common? What are they both congruent to, or what are they both equal to? They're both equal to DEF. So if they're both equal to the same thing, they must be equal or congruent to each other. So ABC is also congruent to JKL. On Monday, I used that example, and they're not here for this example, so I'm going to use Laney's row. If Laney has the same grade as Sareth, and Boston also has the same grade as Sareth, then who else? Then Laney and Boston's grade is also equal to each other. If you're equal to the same thing, then you're equal to each other. Okay? All right. So let's move on. What if we have to start from the very beginning with 2 given statements? Okay. This one's just a walkthrough of this very example, but it should help you with help you kind of try to figure out how we're supposed to be putting these together and help you figure out what things are allowed in order to be able to put them together. So first things first, you put each given statement on its own line. So x over 10 equals 3. Y minus 5 equals 25. And these are my 2 given statements. Now, because we don't always use every single line, or because we end up using more lines sometimes, then you don't want to write your proof. You don't want to write what you're proving on the last line. Okay. But you do look at it as your goal. Our goal is to get just x and y by themselves on both sides of the equation. In other words, I have to figure out how to combine x and y together. To combine a statement, you use transitive and substitution. But to use transitive and substitution, you have to have something in common. Do these have anything in common? Any numbers in common? No. So because of that, I'm going to take my first statement and I'm going to solve it. And I will do my solving on the side. X equals 10, x over 10 equals 3. How do I solve that for x? We multiply by 10 on both sides. And when we multiply by 10, we get x equals what? 30. And we do that using what property? Okay. Now that I look at it, between 2 and 3, we still don't have anything in common. There's no way to combine those two using transitive or substitution. So I'm going to take the second. Now I'm going to take the second equation and solve that. And we do that by adding 5. We get y is equal to 30. If we added 5, then we used what property? Addition. Now that I've solved both equations, I'm able to find something in common in order to combine them. What do they have in common? They're both equal to 30. So if they're both equal to 30, they must be what? Equal to each other. So x equals y. And we did this using the transitive. Questions on this one? Have to find something in common in order to combine the statements. If they don't have anything in common, you have to do some type of solving. Okay. Let's look at the next one. We have 2 given statements. So I'm going to take x plus y equals z. And these are already numbered, so you're welcome. Okay. All right. In order to combine them, first look at your goal. We want y and x, but overall there are 3 different variables, so we can afford to get rid of one of them, which is z. Now, if we look closely, we notice that both equations have a z alone on one side. So that means they're both equal to z, meaning they must be equal to each other. So how do we write that? And we use what property? Transitive. X plus y equals 2x. Okay. And from there, since we're trying to get y by itself, we solve. And we solve by doing what? Subtracting. When we subtract, what do we get? Yep. So that means we're done. The last 2 lines, we didn't need them. You can either leave them blank or scratch through them. It's up to you. Whatever you want to do. Questions? Okay. Ready for the next? Number 5. Still 2, and then we'll get into 3 given statements. All right, the goal is to prove that k is equal to 16. So we either need to get rid of h or we need to get rid of j. Now, they don't have anything in common yet because hj is not the same as j. Okay? Just like, I'm going to pause this because we're going to take that first equation and solve it. 16h. And we're going to get rid of h because when we divide by h, that cancels out. H divided by h, just like 4 divided by 4 equals 1, that's going to equal 1. And 16 times 1 is just h divided by h is 1. 16 times 1 is 16. So we get j equals 16. Cancels out. And we did that using what property? Solving multiple variable equations, that is a literal equation, so that would be something that you should learn in algebra. H divided by h cancels out, or it equals 1. 1 times anything is itself, okay? Now, is there a way to combine 2 and 3? Yes, because they both have what? J. So if they have j in common, I can switch out the j with a 16. Now, if I'm switching out just the 16, would that be switching out part of it or the whole thing? Just part of it, meaning this is which one? Substitution. Okay. And the last step would be to do what? Subtract. And since we have multiple lines here, when you're using substitution or transitive, make sure you also identify or label what lines you used. So I combined 2 and 3. 2, 3. Forgot to mention that one. Subtract 16 from both sides and you get k is equal to 16. So subtraction product. Can't spell. When combining using transitive or substitution, identify what lines, okay? Ready? Especially when we get into 3 given statements and more. Here we go. Ready? Number 6. Go ahead and write your given statements. Now, as you're writing or copying these down, what we learned on Monday is that sometimes, especially if you have 3 given statements, sometimes 2 things can't be combined directly in one step, and you have to combine it. Sometimes you have to combine the first with the last, first, second, or second and last before you can combine to make one statement. So just keep that in mind as we're solving this. And the goal is to get D by itself here. So we can either eliminate A or B to begin with. Do any of these statements have something in common? You can change out 2, or so what would you be combining, Brock? Mm-hmm. Cameron, I saw what you mean, but I don't think there is a name of a property where you can just say 2b equals 4. Yeah. Or that wouldn't be helpful in solving to get D equals 4. 2b equals 4? If 2b equals 4, then 4 equals B. Oh yeah, you're right. Okay. Anyway, we're not doing it. Yeah, because there is not a property because there's an A there. If 2b and 4 were on this, just say it were A plus C equals 2b, A plus D equals 4, then you could say 2b and 4 are the same because they're by themselves. But here they're added to A. Okay. Anyway, but Brock pointed out that 2b is equal to D, so I can put D anywhere I see 2b. Now, because that's only part of the equation, we're only replacing part of the equation, that would be what? Substitution. And we are substituting using what 2 lines? 1 and 2. Are we okay so far? Okay. Now we can actually combine 3 and 4, lines 3 and 4 using what? What do they now have in common? What is something that I can switch out now? Lines 3 and 4. C. If both sides are equal to C, then they must be equal to each other. If A plus 4 is equal to C, A plus D is also equal to C, then they're equal to each other. If Laney and Sareth have the same grade, Boston and Sareth also have the same grade, then their grades are equal to each other. Okay? And that is the transitive property. And here we're combining lines 3 and 4. They're both equal to C, so they're equal to each other. So A plus 4 equals A plus D. Okay, now what do we do to this, to line 5? Subtract A, and if we subtract A, subtraction property, and then we use symmetric 4 is equal to D, we use symmetric properties to switch it around. Okay, questions? Last one, number 7. Three given statements. M is equal to N. N plus P. I need to make my plus sign smaller since we're using T's. And then T equals M. All right. Can't combine all three in one step. What two can we combine? And how? Using what property? What you combine may be something somebody else will combine something different. There is a wrong answer, but there's multiple answers. Let's just say that.
I combine 1 and 2.
1 and 2? Okay. So 1 and 2 have what in common? The N. Meaning since M is equal to N, I can put an M anywhere I see N. They are the same thing, right? And that would be what property? Substitution, since it's only a piece or a part of it. M plus P equals 2T. That was substitution between of equality. Starting on Monday, we're going to be we're going to do this with angles and line segments. Okay. Now what? How can I combine 3 and 4? You can turn M to T. They both have M, so we substitute. P. All right. And the last step. Subtract T. So if I subtract T, subtraction property, what do I get? P equals T. And that is what we were trying to prove. Got it? All right, on your assignment, the first half the lines are already filled out. Your statements are filled out, so you just have to tell me what property is being used.